Good morning. Today we are going to demonstrate electrochemiluminescence experiment using dye photoelectric chips. And first of all, we will see which device we are using. We are using this device, which is from BIODEVICE technology, and the model number is BDT ECLP100. And we can see that the attachment where we will be attaching the deep chip. Here you can see we attach the deep chip, and I will show you how to attach it. So here we will connect our DP chip to the electrode, and here you can see. So these are the three electrodes, these three lines, these are the electrodes, and this is the circle area is our working electrode, where we will be drop casting our either material to modify the electrode and our redox probe. So now I will add redox probe. Here we are using Ruby and TPRA for measuring the electrochemiluminescence. Pause. So now we will measure the electrochemiluminescence for the bare electrode. So for that I prepared the redox probe already, which consists of TPRA and Ruby. So the concentration of TPRA and Ruby is not fixed for all kind of experiments. It depends. We have to optimize their concentration, and we have to mix them, and the ratio should also be optimized. So eventually I have already prepared the redox probe, and now I will drop cast that probe onto the electrode surface. And here you can see that the whole box, we have a dark box, black box, and it should be covered while taking the measurement, so that there is no interference from the surrounding light. And one more thing, that this machine is not only for DP chip. We can use different types of chips, such as drop sense, such as quiescence, but we have to change this connector. This connector should be changed, and it will have a different type of electrode, different type of connector. This white thing, it will be bigger, so that other chips can be connected to this. So one more thing I forgot to tell, that we cannot only change this electrode. We have to change this whole setup, and it is for this device we 3D printed this whole setup specifically for DP chip. But if we want to change the electrode, we have to change this whole setup, and the wire and the connector to the device also. And here you can see that there is a hole here, so this part will get this setup. It will go inside, and it will completely pack everything, so that no interference from any light will be there. So now I will drop cast my redox probe and do the measurement.
Okay.
Right now I am using 20 microliter of redox probe. You can change according to your experiment, or you have to optimize the volume actually for each type of experiment. So we have to be very careful, so that we do not disturb the redox probe, and simply put the whole thing inside. and make sure that it is packed. So it is very important that this material should be soft and and pack everything. If it is hard, it will not, there will be some space left, and that's why we specifically and 3D printed the whole thing. So here we can see the machine. If we can see in closer, okay, I must mention that the photo multiplier is on the top of the electrode. So it will be like this. This is our electrode, and this is the photo multiplier. So it is important to note that when we will change the electrode, if it is a bigger electrode or smaller electrode, we have to position our electrode and PMT in the same way so that they come in the same path. Otherwise our measurement will be interfered with that. So now we will do the measurement. So for that we have two different softwares for that. First one is this C9699210, which is the model number, and we have to double click, open it, and it will be here. It is asking to check the machine. Okay, I started it, and there is one other software for electrochemical measurement. So this is it. Both the softwares will be opened at the same time. And for ECL, we have the usual protocol is we have to go to settings screen, path change. So this is to tell the path where the file should be saved. So I have already made the folder in my laptop. So first we will go to the settings screen, path changed, and I have saved the folder in my desktop. So this is my folder, and I gave the path here. It's done. We have to click here, exit trig, and then exit. So now everything is done. Okay, for ECL you have to decide which one you want, which electrochemical process you want to do. We have chronoamperometry, LSV, linear sweep voltammetry, cyclic voltammetry, DPV, differential pulse voltammetry, or square wave voltammetry. So right now we are going to perform DPV. We can change the potentials, the starting potentials and end potential, and step amplitude and pulse amplitude also. So all those things are set here already, and now we will start with the measurement. So here we can see that the beginning potential is minus 100 millivolt, and end potential is 1000 millivolt. Usually it's a default setting, and step amplitude also you can see here 100 millivolt, and pulse amplitude is 50 millivolt. So again, going to the ECL thing, again I will show so that there is no confusion. While every time whenever you are going to do the measurement, always go to settings screen, then path changed, then go to the folder where you want to save all of your files, select, and it is done, and you have to click on the exit trig, then exit. Okay, now we will start the measurement. So we have to be very careful about one thing. Whenever we are starting this ECL thing, we have to right away, when we start this, we have to start the electrochemical thing also. So I will be very quick on that, so that's why I'm telling you before. So first we will power on and start, and the name of the folder, I am keeping it 1 here, and just after that we will start this also. So here we can see the measurement is started already. It looks like this, but after some time you will see there is a fine peak of the ECL measurement. and we have to be very careful. As soon as it stops this, it stops running, we have to power off the machine and then check how much is the value. Here you can see it is 200,000 RLU, and here you can see this is the DPV result. The current is around 6.5 microampere also. One more important thing, to get a stable reading, we have to do it several times. In some cases it is 10 times, 15 times, 20 times. So you have to do that. So using it is important that I should say that using the same electrode. So here you can see in the second run, the reading we got is more than 200,000 RLU. It is now around more than 240,000 RLU. So we have to get this reading, the peak reading stable. So for that we have to do it many times. For this time I'm again doing that, so that you get an idea that every time it is increasing and we have to wait for it to be stable. And you can see it is a little bit blurred. That means it is running. As soon as it gets red properly or clear, you have to switch it off. So it again increased up to more than 60,000, and here you can see the EC reading is consistent, but the ECL reading is peak intensity is increasing, and we have to do, as I said, we have to do it many times so that it gets stable. So that's the good thing with the printed electrode which I used. So you don't have to polish every time, or especially polish and wash it and clean it every time. So what happens with the bulk electrode, every time you will get different readings, but with the printed electrode we will get almost similar reading for every time. So here we use a bare electrode which is not modified at all. It is directly came from company and we are using it. To do our experiment, we modify with different materials and we get the desirable results. And when we have to stop with the increasing reading, so there will be a time after 10 or 15 readings, it will stable and it will start go down. So that's the point you have to stop, and you have to take three consecutive readings at that point, and you have to take that for your experiments and for your data. Okay, now important aspect is getting the data. So we did our reading. So after every reading we have to save the data to our folder. So it will directly open that folder, and if we are giving it, we have to give it a name. So suppose I gave it the name 2. So okay, and it will save. So now we will go to our path, and here we can see 2 data are saved already. Here you can see this is the time and this is the intensity of the ECL, and here you can see the at 12 seconds it is giving the highest result. So we have to take the whole thing and plot it where you want to plot, which software you are going to use for your data analysis. So we'll again do it so that you get it properly, that how to save the data and how to perform everything. So let me start with the beginning. So we will start with the software. First ECL, then so for ECL it is the C969210 software, which is specific for the machine BIODEVICE technology, and this is the KME USB stat software for electrochemical measurement. And we have to open both. We have to Setting screen, change the path. We have already given the path. Select it, click on exit trick, then exit from here and power on and start. Give the comment. I'm giving 1. It will start measuring the whole thing. And as soon as we will start the electrochemical thing, it will start measuring. Here you can see. And after some time you will see that it is giving, and we have to check whether as soon as it gets clear, this power on thing, we have to stop it, save the data, 2, 3, OK, go to the folder and you can see we have saved the data. Open it in Excel file and you can see the whole thing is already saved. Up to 29 seconds it ran and we got the highest reading around 12 seconds. For every reading you are taking, you will get the same thing. If it is the same electrode and you are doing the same thing again and again. Here you can see there are 2 types of file are saved. One is Microsoft Excel and the other one is PAR file. We don't use PAR file for anything because all the data is saved here in Excel, and we can use this data for our analysis. So don't worry about this PAR extension file. It's for the software, it's for the machine. The machine is saving the data in its format. So now what we will do, we will compile all the data in one single file and plot it just to understand how it is, how it is shown. So this is the first data. And so time will be same for all the data. For one electrode, how many readings we are taking, we have to, the time will be same. So and this is the ECL intensity. Here we are taking from other file. We will simply copy paste and here, and this was the second file, and this is the third file. So we have to plot the whole thing. Suppose. So now I'm going to plot my data. So I copy the time from the Excel and put it on Origin. So we have this Origin software in our lab for all the data analysis, and then I copied all the intensities and put it here. So we have 3 intensities, 1, 2, 3, and we will plot all together. So in the meantime, I ran many times, and I got the almost similar reading for I got the stable readings. So I am going to plot everything, and now here you can see the intensity, all the 3 intensities are almost same. So this is the average of this maximum intensity is our our optimum initial intensity for this bare electrode, average of this one. So what I did, I plotted the time first. So this is the time you can see. From 0 to here, and this is the data, and then select everything. So for this type of reading, for electrochemical and ECL data, we have to select this line plot, and we will click on it, and there will be a a plot like this, and after that you can change the plot how you want to make the line and everything. If you want to make the line a bit thicker, you can do that from the settings and all. So you can change the line, you can rename this by 1, 2, 3. You can change that, and you can change the font size of these readings. You can, from here, suppose you can change the scale and everything. So that is for origin part, but here we can see all the 3 are same. When everything is done, we have to save the file. So if we have to save the picture, we can go to the export graphs, and it will open. You have to put the resolution whatever you want. There are many, and here you have to change the folder, which folder you want to save. So my folder is on desktop, and here this is ECL, and it's click OK, and it will be saved there. And here apply, it will take some time, and then OK, then my everything will be saved there, and we can go and we can check there also. So this is my desktop folder, and this is ECL, and here you can see the graph is plotted in a JPG file. You can change the pixel, and you can change the format also after that. So now we will close everything. Yeah, one more thing, to save this origin file also, we can go to file, we can save project as, and suppose we are saving in the same folder, we can go to the folder, rename the folder ECL or whatever you want to put the name, and then save it. It will be saved. Now we will go there and check. You can see here there is a origin file, Unicode origin graph saved here. If you will double click on it, it will open in origin again. The whole everything, your workbook also and your figure also. Now I will be taking the sample out. So very carefully take out the whole thing and take out the, we have to be very careful because it is very sophisticated. Take out the electrode. So we cannot reuse this electrode because either it is modified or it is being already used. We have to throw it properly, and then again we have to put it back so that it will be convenient for the other person. Close everything and shut down the whole computer. We will close all the softwares from here and ultimately shut down the computer.